Okay, Jane, here we go with this problem. There's quite a lot to it. This t sub 20 tells us we're going to use the trapezoid rule. A is going to have a value of 0. B is going to have a value of 8. The width, and there's going to be 20 trapezoids. Now, to answer this question, whether the trapezoid rule overestimates or underestimates the value of this definite integral, you have to know that on the interval from 0 to 8, this function is strictly decreasing. And how can you know that? Well, if you let f of x equal 2 to the 2 times e to the minus x over 4, f prime is going to equal 2e to the minus x over 4 times negative 1/4, invoking the chain rule, which is equal to negative 1/8 e to the minus x over 4. And the point of all this is that this expression right here, this is an x, no matter what value I put in for x, is going to be negative, which means we have a situation like this. The first derivative is negative, so the tangent lines are always decreasing, and the slope of the tangent line is negative, so the original function is always decreasing. So this is a decreasing function, and if you, well, let's go to the next board. Here's a graph of this function, and I've calculated the x sub 0, f of x sub 0, which is this point here, 0, 2, and x sub 1 would be 0.4, because delta x is 8 minus 0, b minus a, over the number of subintervals, 20. And so this point is 0.4 comma 1.8 something or other. And the point is that this leg of the trapezoid is above the green line, which is the graph of the curve. So we overestimate the area of the area under the green line by this little smidgen amount right here. So the answer for part 1 of this is that the trapezoid overestimates, and that's because, again, because this is a decreasing function. Now, find the error bound for t sub 20 without calculating t sub 20 using this formula right here. So where they tell you that m is the least upper bound for all absolute values of the second derivatives of the function blah blah blah. So let's go to board 3. I've actually calculated the first and second derivatives, and you can pause the video to confirm. Oh, by the way, I just realized that on board 1 I said this was what did I do here? I said this was minus 1/8. It should have been minus 1/2. I made that mistake earlier. 1/4 times 2 is negative 1/2. Okay, so back to board 3. So it's the second derivative that has this 1/8 out front. And this capital letter M is supposed to be a least upper bound for the second derivatives on the interval from 0 to 8. And once again, if you thought about this function, g of x equals 1/8 e to the minus 1/4 x, and found g prime, you would get negative 1/32 e to the minus 1/4 x, which is always negative. So this function right here is always decreasing, which means the maximum value is going to occur when x is 0. And when x is 0, the second derivative has a value of 1/8. I know that on board 1 we said that m is the absolute value of all the second derivatives. So this is the least upper bound. That's the smallest number that's greater than or equal to every value of the second derivative on the interval from 0 to 8. So m is 1/8. b minus a would be 8 minus 0. That's cubed. And 12, n is 20. So the error, the maximum error for using the trapezoidal rule for 20 trapezoid is less than or equal to 1/75. Now I know they said on this problem not to calculate t sub 20, but I did it anyway. Okay, so I found x sub 0, x sub 1. You can see I found all these x sub, all the way to x sub 20. And then I calculated t sub 20 right here using delta x over 2 times f of x sub 0 plus 2 f of x sub 1 all the way out to plus f of x sub 20 at the end. And t sub 20 has a value of 6.92308, blah, blah, blah. And then I actually calculated the value of the definite integral using Desmos definite integral function, and it came up to 6.9173. And then I calculated the t sub 20 using the trapezoidal rule, take away the actual value of the integral, and I get 0.0057, which you can see is less than the error of 1/75. Okay, so that's how you answer this part right here, less than or equal to 1/75. And the tricky part is determining this least upper bound. You have to take the second derivative of the integrand, this thing right here, and determine what's the smallest value that's greater than or equal to every value of the second derivative on the interval from 0 to 8. And as we saw, that was 1/8. Okay, so I'm going to end this video and send it along to you.